An expression for Pascal.
Could you guys just share your screen?
Yeah, that's what I'm gonna do.
Yeah, me and Andy are working on that problem right now. I think this one's the trees you were talking about that you haven't studied yet.
Yeah, so this one's like the precedence thing. Um, which let me share my screen. Yeah, it's like the one time I get to yet, but that one's not too hard. I think you just have to go in order, which I will actually show that. Let me just share my screen on my iPad. But I guess we'll go in order. Let me bring this up. Okay. So this is from the review sheet I made. It's about 18 pages. Just kind of covers everything and goes over some problems as well. So in order, it goes over one, writing recursive descent parsing code based on EBNF rules. So that's just a TinyJ assignment 1 questions, which that's just using get current token, next token, accept, and then like that token, things like that. For that one, you need to know things like, um, L paren, R paren, L bracket, R bracket, L brace, R brace, um, plus, minus, things like that. That's what you need to know for question 1. So if you haven't done TinyJ assignment 1 yet, at least try to do it tonight or something. I don't know, but you should have TinyJ assignment 1 done. And then question 2, part 2 is hand translation of TinyJ source code into TinyJ virtual machine instructions. So again, that's just a TinyJ assignment 2. So if you've done TinyJ assignment 2 and you understand that, you're good. But the actual exam is not going to have like, new add instruction, new sub instruction, new div instruction, new jump on false instruction, whatever, right? It's not going to have that. Hand translation is just like actually writing like through each address and things like that. So if you understand that, you're gonna be good. Which we're gonna go over the rules for that and everything. And then part 3 is just questions relating to TinyJ assignment 1 and TinyJ assignment 2. These can be random questions, so I really don't know what they could be. I don't know if anyone has any past exams or anything like that, but all right, actually, Andy, you took exam 2 last semester. What does it mean by questions relating to TinyJ assignment 1 and TinyJ assignment 2?
No idea. I think for the past exam, no, yeah, like he can. I'm thinking. No, I don't think we have any. We didn't have any questions on that. Last exam, I think I took it was just 1, 2, 4, 5, and that's it. It wasn't 3.
So you didn't get questions that were like
I think on the
new
final there was,
yeah,
but
but
not on.
you didn't get
Not
questions
on
that were
those.
like new add instruction, new sub instruction, things like that.
Nah,
Okay,
no.
good.
Like right now everything he gave us like is like what you should expect to see on the test.
Yeah. Okay.
Like all the problem that he told us to do, everything, like just practice. Literally like the hands translations were like copy for copy on like what he gave us in like the exam 2 notes on his website.
Yeah.
Literally same thing. And then like you said, Tiny J assignment 1, if you didn't do it, you're kind of fucked for the test because there is guaranteed one question on there. And then depends on how nice he is for it. But oh wait, let me just look at assignment TJ assignment 1 real quick. Because it's not gonna be an easy one. It's gonna be a one with a bracket and a curly bracket for sure. Like so you're gonna have a while and an if. And I think he doesn't go harder than that.
Yeah.
And then yeah, that's it. Yeah, that's it. I'm thinking of the final. Yeah, that's it. Like for exam 2.
Okay. So that would basically just be 1 to 3, and then for 4, we have BNF, eBNF, and parse trees. So again, BNF is just what we did in 320. If you're here, you should know what context-free grammars are. But that's basically just what it is. And eBNF is just an extended version of that, where it allows for optionals, while loops, or not while loops, just loops, and groupings within your grammars. And then parse trees, you're basically just converting some expression given a grammar to a parse tree, where you would read the nodes of that tree, or sorry, the leaf nodes of that tree from left to right, and you would get the expression again. So you need to know how to draw parse trees, both in its normal way and its sideways way. That's just called a sideways parse tree. So that's number 4. The number 5 talks about syntactic ambiguity, derivations, expression grammars that reflect the associativity and precedence of operators, which that is 2.10, and syntax charts. So the easiest ones for number 5 are syntactic ambiguity, derivations, and syntax charts, where syntactic ambiguity is just saying, okay, is a given grammar, is it syntactically ambiguous or not? To be syntactically ambiguous, it's just saying, okay, is there some string in this grammar that has 2 parse trees that give the same expression? That's just syntactic ambiguity. And then derivations is just left derivations and right derivations, where let's say you're given some grammar and you want to turn into some expression. If it's a left derivation, you would evaluate the non-terminals starting at the left. And if it's right derivation, you would evaluate the non-terminals starting at the right. And then syntax charts, those are similar. Those are similar to finite automatons, if you want to think of it that way. But we'll get more into that a bit later. And then expression grammars that reflect the associativity and precedence of operators. Could you send the review sheet after too? Yeah. So yeah, expression grammars that reflect the associativity and precedence of operators. That one, I don't think I put on this review sheet because I didn't get to it yet, but I got to everything else except for that. But we'll get through everything and then we'll kind of go over that together. We should be fine. Okay. So let me just keep this chat open. And we'll start at number 1. So number 1, again, this is just writing recursive descent parsing code where we're using get current token, next token, accept token, and combining your code with non-terminals and terminals, or tokens if you want to call them. So get current token just returns the current token. Well, it doesn't return. Oh yeah, sorry. It returns the current token that the grammar is pointing to. And next token assumes that the current token is correct in our current grammar and moves to the next token. But it's best to check beforehand with some if statement. So you can say if get current token is equal to whatever token you actually want, then you would say next token. Right? So in this example, let's say you want to check if the current token is an identifier. You don't want to automatically assume that it is and say next token. You would say if get current token is equal to ident, which that's just from the token list. So if get current token is equal to ident, run next token, and you're good. And then accept symbol is the same as next token, except it does the check for you. So in this case here, accept ident is the same as saying if get current token is equal to ident, next token. Okay. Any questions about next token, get current token, accept? Here got stuck. Okay. Good. But remember what we're doing is we're converting an eBNF grammar to Java descent parsing code, right? So you also need to know these terms over here. So a non-terminal is a production in an eBNF. So basically it's just like that one whole line where you'd have the name of the non-terminal, then dot dot, then you would have colon colon equals, and then the rest. That is a production. Okay. And then a terminal or a token is a symbol in that production that doesn't reference some other non-terminal, right? So it could just be like the number 1, the letter A, anything like that, some variable, anything. That's what a terminal or token is. Parentheses, so left parentheses, right parentheses, that just represents a grouping. And then brackets, that just represents a optional statement. So that means that you can either have whatever is in that bracket, or you won't have it. And then the braces, which is over here, don't confuse the words bracket and brace. If you see squiggly line, that is brace. If you see the sharp edges, if that's what you want to call it, that's brackets. But braces represents 0 or more instances of what's inside the braces. Okay. And then finally, the line here, that just represents this or that, right? So you either would have what's on the left side or on the right side, right? That's all it does. So here's an example. Let's say we have this grammar here called compound statement. Okay. And this grammar, it has 2 tokens, one right here and one right here. And it has a continuous call to a non-terminal called statement. Okay. So the first thing we need to do in this descent parsing code, our descent parsing code method, is we first need to accept a left brace, right? Notice that it is in like quotes, so that's an actual token. It's not a reserved symbol like these. So this is an actual token, so we need to accept a brace. And then once we get here, we need to run statement 0 or more times. And we would know to run statement based on the current token we're looking at. Okay. Now the token that's after this while loop is a write brace, right? So what we can do is we can say, okay, while the current token is not equal to a write brace, we run statement, right? And then once it is equal to a write brace, then we can just run accept write brace, right? And that's exactly what we do. Or over here, we accept left brace, and then while the current token is not equal to right brace, we run statement. And then as soon as we break out of the while loop, we run accept our brace. Now, there's these other things in this code that I'm not sure if you need to know. I don't know if he's going to give this to you already. But the first line of your code should be tj.output print symbol. And then that's just going to be the non-terminal of the method. And then you also need to output some incrementation to the tree depth. So basically, as you're running this, it's also going to be outputting a sideways parse tree. So that's just what it's doing, where it's going to print the symbol. So it kind of looks like this: compound statement, and then it's going to increment the tree depth. So now it's going to start here, do whatever it needs to do. Once it's done, it's going to be like this: no more nodes, and then it would write the rest here. So that's what the deck tree depth is. It's going to go back to the left. Okay, but that's pretty much it for this. But there are some special cases which we'll go over here. So here's another example. We have assignment or invoke, which if you did TinyJ assignment 1, you'll remember this one, but we go over some ones that aren't done in TinyJ assignment 1, and they are they're in the code, but they're already answered for you, so you probably didn't know how to do them. So assignment or invoke, first thing we have is an identifier. The symbol or token for identifier is simply ident. Okay? Ident. So the first thing we need to do is accept ident. So that's what we do, accept ident. Okay? And then here we see that we have a grouping, right? From here to here. And in this grouping, we can either have this or this. Okay. So either one. Now, if we have this one, we again have two options. We can either one, start with a left bracket, or two, start with an equal sign. Okay. And we have the option to start with a left bracket because we have this loop here that will make sure that it occurs 0 or more times. But if it occurs 0 times, then the equal sign is going to be the first token. So that's why this portion here has two options. Again, it could either start with a left bracket or it could start with an equal sign. Now remember, the symbol for left bracket is just left bracket. And the symbol for the equal sign is becomes. Okay, so we have becomes and we have left bracket. Okay. So what we're going to do is we need to determine if we're on this side or on this side. And what we can do, the way we can do that is we can say, okay, if the current token is equal to a left bracket or the current token is equal to becomes, then we're on this side. If it's not, then we're on this side and we just need to run our argument list. Okay. So here we say if the current token is equal to left bracket or the current token is equal to becomes, then we know we're on this side. So the first thing we need to do is this while loop here. So we can say while the current token is equal to left bracket, that's referring to this one here, we're going to run next token because that certifies that that was a left bracket. But if you wanted to, you could replace next token with accept left bracket. So you can either again do next token or accept left bracket. Right? And then we need to run expression 3 and then accept a right bracket, which is right here. Then once we break out of this while loop, we see that the next thing we need to accept is an equal sign. And this equal sign is represented by becomes. So the next thing we do is accept becomes. Then here after equal signs, we run expression 3. So expression 3. And then here we see we have a semicolon. So we need to accept semicolon as well because the token for the semicolon is simply just semicolon. Okay. So any questions about this first if statement here? Nope. Okay. So let me bring this up. Okay. Now, if this wasn't true, again, that means that we're on this side. So the first thing we're going to do is call an argument list, which we know to be a non-terminal. So we can simply just call it by saying argument list with no parentheses. And then to the right of that, we see we have a semicolon. So we're going to run accept semicolon, which is right here. Then that is it. That's all we needed to do. So we run.
Sorry. So instead of doing argument list, can we just do, like accept? No. Never mind.
Yeah, so if you encounter a non-terminal, you can't do accept. You have to actually call the function. So that's why we did it that way. Okay, so that's all we needed to do. So then we just deck tree depth, which again, I'm assuming he's going to write this out for us. tj.output print symbol, then the non-terminal name, and then ink tree depth, and then deck tree depth. I'm assuming he will, but if he doesn't, it's safe to memorize that part as well. Okay. Any other questions about this grammar here? Nope.
Can we do a if statement?
Sorry?
Can we do a if statement?
Oh yeah, we can. Just we're gonna do this last example. Yeah, we're gonna do this last example over here. I think
No
these are the
problem.
same
It's
ones.
just
Yeah.
like I have a really strong feeling he will put if statement in the exam.
Mm. No, yeah. So we'll do this one, which this one wasn't in TinyJ assignment 1. This one's good to know, and then we can try if statement. So this one, we see that we have a grammar called a statement. Okay. And we see that we have a bunch of different options to start. We have a semicolon, we have return, we have var dec, we have assignment or invoke, compound statement, if statement, while statement, and output statement. Okay. Now the easiest to do first is going to be these, right? Because you can easily just say, okay, if the current token is a semicolon, then we know that we're in there, so we just have semicolon. And then if we're in here, we say, okay, if the current token is return, then just accept return, and then you optionally run expression 3, and then a semicolon. But here with var dec, assignment or invoke, compound statement, you can't just say if the current token is equal to var declaration. That's not how that works, right? Because if you do that, you're trying to compare a token to a non-terminal, which those are not equivalent or equivalent types. So you can't just go ahead and do that, right? And so what you need to do instead is, let's say we're in var declaration, you need to actually go to the grammar for var declaration and see what are the options for the first tokens of var declaration and check for those instead. Okay. But first, let's get the easy ones out of the way. So for semicolon, if the current token is equal to a semicolon, we're going to accept semicolon, which that would just be done with next token, or you can just do accept semicolon. Here, if the current token is equal to return, we're going to accept return or just call next token. So for return, we call next token. And then we have this optional statement here. The way we can deal with this optional statement without having to go into expression 3 is we can say, okay, if the current token is not equal to semicolon, run expression 3. And then outside that if statement, accept a semicolon, which that's done over here. If the current token is not equal to semicolon, run expression 3. And then finally, accept semicolon. Okay. So that deals with this, and that deals with this. Right? But now we have to figure out var declaration. So for var declaration, let me bring up the website. Let me see if I can find it. Pretty sure I had it here. I might not have. Oh, okay. Oh no, should be on 1. Okay. So you would on the exam, if he were to like reference some like non-terminal and you need to like later reference that, I'm pretty sure he would tell you that grammars for that specific non-terminal. But here we have to reference this. So the first thing we do is for var declaration, we're going to go to var declaration and see, okay, what are the possible first tokens for var declaration? Well, we see that the first possible ones are int, right? Int and scanner. So either or, right? So what we can do is we can say, okay, if the current token is equal to int or the current token is equal to scanner, run var declaration. So here we say else if the current token is equal to int or the current token is equal to scanner, we run var declaration. Okay. And that takes care of this part here. Okay. Next, for assignment or invoke. Assignment or invoke we did up here, which the first token for assignment or invoke is identifier. So what we can do is we can say, okay, if the current token is equal to identifier, run assignment or invoke, which that's done over here. Else, if get current token is equal to ident, run assignment or invoke. Okay. So we did boom, 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 boom. Now we have to do compound statement. Well, compound statement we also did over here, which the first token is a left brace. So for that, we can say, okay, if the current token for compound statement, if the current token is equal to left brace, run compound statement, which is over here. Else if get current token is equal to left brace, run compound token. Compound statement. And now for if statement. For if statement, let's bring up if statement, which is over here. Which if statement, we see that the first one is just if. So what we can do is we can say if the current token is equal to if, run if statement, which is right over here, if statement. And then for while statement, let's bring up while statement. The first token is while, right? So we're going to say, okay, if the current token is equal to while, run while statement, which that is over here. Okay. And then finally, we have output statement. Now there's two different things you can do here. For output statement, where's output statement? Right here. We see that the first token is system, right? And that's represented by the symbol all caps system. So the two different things you can do is either A, say, okay, else if get current token is equal to system, then run output statement. Or you see that this is the last case. And since this is the last case, you can just run else. So over here, we say else, and then we put output statement inside the else. And that's it. That's all you have to do. Okay. Any questions about statement? Are we all good with that? Or any questions about going into the actual non-terminal and grabbing the first token? Nope. All right, and just give me 1 second. Someone's messaging me. Okay. So, you said that you wanted to do if statement, right, Olivia?
Yes.
Okay.
I'm listening.
So for if statement, I'll bring it up like this, which this one is pretty quick. Okay. So for if statement, all you have to do is we know that this is the grammar. So we're gonna have it should be public, no private. Okay. Private static void if statement. Then I think you have to throw source file exception. So remember, the first thing you need to write is tj.output.print symbol parentheses nt if statement, and then you would do tj.output.ink tree depth. Okay. And now we see that the first possible token in the if statement is just if. So we're going to say accept if. And then we see it left paren. So we're going to say accept L paren. And the next is expression 7. So we're just going to run expression 7. And then accept R paren. Okay. Then the next thing here is statement. So we're going to run statement. So I can fit it here. And I'm just going to write the rest here. Right, so we did boom, 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 boom. And now the final part is else statement. For here, we see that it's optional. So we can say we could say if get current token is equal to else. We're going to say next token and then statement. And
I
then
just have a
finally,
quick question. So every time when we write like a if or while or with the next sentence, or we always get is get next token.
I wouldn't say always, because there it could be like for some reason or for some different reason. But usually, when you're writing an if statement, it's probably because you're checking the current token. So you would say if get current token is equal to, and you would compare it to some token.
So when do we use next token?
You use next token if you already know what the token is. So here, if get current token is equal to else, if we go inside the if statement, we already know what the token is, so we use next token, right? You never want to use it unless you know what it is. Sorry, you only want to use it if you already know what it is. If you don't know what it is, then you want to use accept and then the symbol instead. You don't want to say next token every time.
Okay, thank you.
Okay. And that's it for if statement, right? That's all you needed to do.
Thank you.
Mm-hmm. Okay. I think I had one more example before two. Let me see which one's harder. Parameter. Oh, actually, yeah, this is just one example here. Okay, so we'll go over this one really quickly, and then we're going to go over to virtual machine code. Okay. So here we have this. We have two grammars here. Two productions here. We have parameter declaration list and parameter declaration. Inside a parameter declaration list, we are calling parameter declaration, and inside a parameter declaration, all we're saying is int identifier and then 0 or more left parens and right parens. Okay. So the easiest one to do for parameter declaration is we just have int identifier and then optional left parens and right parens. So we're just going to say accept int, accept ident, and then we're going to say while the current token is equal to left paren, then say next token, and then accept right paren, which is exactly what we did here. Next token, which again, if you don't want to do next token, you could say accept left paren if that's more comfortable to you, but there's no reason to check twice, so that's why I do next token. And then accept right bracket. That's all we need to do for parameter declaration. Then for parameter declaration list, we see that it's a bit different. Where here, this entire thing is optional, right? It's not just a part of it, the entire portion is optional. So the entire portion is optional, but the first token is a non-terminal, which again, we can't just say if get current token is equal to parameter declaration, right? We can't just do that. So what we need to do is find the first possible tokens of this and then check. So we would say, okay, if the current token is equal to int, then run parameter declaration and then run this part here because they're both inside the same optional. So here we say if get current token is equal to int, we run parameter declaration. And then in here, we see that we have 0 or more commas and then a call of parameter declaration. So we can say while get current token is equal to comma, run next token, and then run this function. And that's exactly what we do here. We say while get current token is equal to comma, run next token, and then run parameter declaration. And that's it for this one. Oh, also, again, since this isn't optional, right, the entire thing is optional, which you can either have something or you don't, right? So if this portion here, if that never happened, then the result would just be empty, right? So you can say else, you want to print the symbol empty. So else tj.output print symbol empty. Okay. And that is it for parameter declaration list and parameter declaration. And that also pretty much wraps up number 1. But is there any other ones from here? Is there any other ones from here that you guys would like me to do? Any of the harder ones or anything like that? Yeah. Anything you guys want me to do from here? If not, then I'm going to move on to virtual machine code. These aren't too bad. And also, again, feel free to try these yourself. Because you can try it yourself and then just compare your answer to what's in the parser.java text file for assignment 1, because the answers are there. Okay. Can you do one of the expressions? So down here. If anything, I could just do expression 1. I feel like that one looks harder.
Yeah, sure.
Okay. So let's go to expression 1, which actually I think he did expression 1 for us in TinyG assignment 1 because I think it was too hard. So let's see if we're even able to do this. I probably doubt it, but let's see. Let's try to do at least some of it. So let's bring this one up. Okay. So first things first, we're going to write the title line. So private static void expression 1. Oh. Throws source file exception. Okay. And we have to go ahead and examine which ones are possible. Okay. So we see here what's possible is a parentheses. We have new, ident, we have unsigned int, we have null, a bunch of different things that are possible, right? But we see in this case, this is where it gets tricky. Right? Actually, no. No, it doesn't get tricky because you can just have plus, minus, or not. Okay, sorry, my bad. I'm being stupid. And I think that's all the cases that we have. Yeah. Okay. So, first things first, we need to print the non-terminal we're at. So tj.output. And this is the last of the topic number ones that we're going to do. Print symbol nt expression 1. And then tj.output ink tree depth. Okay. So first things first, our first case is a left parentheses. So we're going to say if get current token, if that is equal to a left parentheses, then we're going to run next token and then run expression 7 and then accept a right parentheses. So next token, expression 7, and accept right parentheses. Okay. Right. So that is the first case. Else, if the next case is either plus, minus, or not. Okay. So we're going to say else if get current token is equal to it's going to be plus or get current token is equal to minus or get current token, oh, it's kind of breaking off, is equal to not, right? Because this is plus, this is minus, this is not. If that's true, then we're going to run next token. So next token. And then from there, we have to run expression 1. So we're going to say expression 1. Okay. Then here we have unsigned int. I believe the token for that is literally just unsigned int. So else if get current token is equal to unsigned int, which actually, is someone able to confirm if that's just unsigned int? Pretty sure it is.
Yeah, you're good.
Okay. So if this is true, we're just going to run next token. I think the only one that's really different is identifier, which that just reduces to ident, which I don't know why he did that, but yeah. Next we have null. So else if get current token is equal, I believe it's just null. So if this is the case, run next token. Which if you wanted to, we actually could have combined these two. We could have said else if get current token is equal to unsigned int or get current token is equal to null, run next token. We could have done that if we wanted to, but I'm lazy. And then we have new. So else if get current, which you would have been able to write less if you just did a switch case instead, but if you're unfamiliar with switch cases, you can just do ifs and else's as well. So else if get current token is equal to new, we see that we want to accept new, then int, then a left bracket, then run expression 3, then accept a right bracket, and then have a while loop that does a left bracket and a right bracket. So we're going to say next token, then the next is int, so accept int. Then the next is a left bracket, then expression 3, then a right bracket. So accept left bracket, expression 3, then accept right bracket. Okay. Then we have a while loop that continuously just accepts left brackets and right brackets. Okay. So we're going to say while get current token, while that's equal to left bracket, we're going to run next token and accept right bracket. Okay. And that's it for that else if. We're out of room. Okay. And then the last case is this one. So if we wanted to, we could say else if get current token is equal to ident. But since this is the last case, we don't need to do all that. We can just say else, right? So else accept, which I would say accept ident because we didn't actually do a check. We're just assuming that we're looking at that. So I'm going to say accept ident. Okay. Now here we have this grouping. The first element of this grouping can either be dot or whatever is here. Now the easiest thing to do is just check if it's dot, and if it's not dot, then it's just whatever this is, right? If we check this first, then it makes it harder because we have a bunch of conditionals and we don't want to have to deal with that, right? So we're going to say if get current token is equal to, and I believe it's dot. Someone could correct me, but it should be dot. If that's true, we're going to run next token. And then the next symbol was next int, which I believe the token for that is just next int. Is that correct, Chrysler?
Yeah.
Okay. And then finally, we just accept left paren and right paren. So accept left paren and accept right paren. Okay. And that handles this part here. But now we have to handle this part. Okay. So here, we see that we have a bunch of optionals. We can either start with argument list or have something here. We can either not start with argument list and start with something here. We can have nothing, or we can have argument list with nothing here. Right? So to do this, I'm going to first check if there is an argument list, right? Which, if we're going to do that, we need to check the first token. So for argument list, I don't think we did that one, right? So I have to actually check here. Argument list, the first token is a left parentheses. Okay, so we're going to say, right here, we're going to say else. And how can I do this? We're like running out of room. I'm going to get rid of this. And I'm going to move this up. Okay. So now we need to check if we have a left paren. So if get current token, if this is equal to a left paren, okay, then of course we need to run argument list, right? Because if we go back to expression 1, we saw that it was argument list here. And then we're going to say while we're looking at a left bracket, we want to accept left bracket, then run expression 3, and then accept right bracket. So we're going to say while get current token is equal to left bracket. Still running out of room. I'm going to.
Idea.
Huh?
I have an idea. Like,
Mm-hmm.
we don't check the we don't check the what was it? We don't check the dot. We just say if get current token is not equal to the dot, then we go to the argument list.
Well, remember the for actual argument list here, the argument list can either be there or it can't. Right? So we can't just assume if there's not a dot, we just run argument list. Because if there's not a dot, yes, we would be on this side, but there may or may not be argument list there. Right? That's why we had to separate it.
Okay, thank you.
Mm-hmm. So,
Also, Justin, real quick, there should be a next token after the if statement. If current get current token is up, Brennan, before the argument list call. Next token.
Here.
Yeah, you check if the current token is up.
No.
We
did
that.
I'm
dumb. Sorry.
Yeah. No, you're good. You're good. Okay. I'm just gonna do this because Java lets you do this. I'm just gonna write on the same line here because we're running out of room. But next token, and then we need expression 3. So, I'm going to put expression 3 here, and then accept right brackets. So right brackets. Then I'm going to close up this while loop. And And then I'm going to close up this if statement. Oh, wait, no, hold on. I might have fucked up. This should be, let me move it over. This should be over here. And then let me just, because we're running out of room, I'll put the bracket there. Then we have this else statement. And then this else statement is inside of another else statement. And then we would need to write the TJ output.deck tree depth. Let's just assume that I have that there. So I'll write TJ. And then to close off the method like that. Okay. And this is the code for expression 1. So any questions about this? Yes, no. All right. So that was expression 1. Again, I will send this PDF after, so if you need to, you can look back at it. But now we're going to move away from descent parsing code. That's what it's called, right? I'm blanking. Yeah, we're going to move away from descent parsing code, and we're now going to go to virtual machine. So virtual machine, again, this is part 2. We need to hand translate Java source code into Java virtual machine instructions. Okay. So again, you're going to take Java source code and line by line turn it into Java virtual machine code. Okay. The fuck did I write there? Instructions. Instructions are executed using the expression stack. So remember, you need to visualize yourself as you're putting the result of expressions or running instructions on a stack. And if you just visualize it that way, which again, that's exactly what it is, which you have to visualize it that way. But if you understand that idea, then you'll be able to do fine. But just give me 1 second. Let me sorry. I forgot I need to turn in my assignment. Let me just copy the link really quickly. Apologies. Which Chrysler? Can you give me one? I need. Can I send you this link? Can you just let me know if you can open it real quick?
Yeah.
Just don't add anything. Just open it and then go to slide 4 and see if you can click that audio and you can hear it. And if you can, I'm gonna submit it real quick.
All right.
Just go to slide 4.
Yep.
Can you hear it? All good?
Hold on, my fault. Let me. Yeah, I can hear it.
Okay. So let me just submit this real quick. Sorry. Login. Assignments. Group project. Create submission. Okay. The above link is the link to my presentation. Audio. I work with Group 2. Okay. That should be good. Okay. Submit. Okay. So, virtual machine code. Again, you have to think of this as we're on a stack and you're going line by line in a Java source code file, and you're evaluating instructions via that stack, right? Which I'll go over that a bit more. But first, we have to go over addresses. So addresses, for every global variable, it's tied to an address, right? An address in data memory. And that address starts at 0 for global variables. Okay, so all global variables, they start at address 0. Okay, and you read them. So let's say you have int x, int y, int z. You read them in the order they come. So address 0 is going to be for x, address 1 is going to be for y, and address 2 is going to be for z, and so on. Okay. Local variables are also tied to addresses, but they start at +1, right? So let's say we're inside some method, and let's say we have the local variables int c, int y, int c, int d, int e. Int c is going to be tied to the local address +1 or offset +1. Int d is going to be tied to +2, and int e is going to be tied to +3. Okay. And then finally, variables passed as parameters to functions, they're tied to addresses, but starting at -2 from right to left. So let's say you're reading the parameters of a function. Let's say we have int g with the parameters int x, int y, and z. Int z would have address -2. Int y would have address -3, and int x would have address -4. Okay. So here's an example. Here we have global variables x and y, local variables m and n, and then parameter variables a, b, and c. So x is going to be at address 0, y is going to be at address 1, m is going to be at address +1, n is going to be at address +2, c is going to be address -2, b is going to be address -3, and a is going to be at address -4. Okay. And that is what is happening over here. Okay. Any questions about addresses? This is a very important topic. No? Okay. And then also, it's good to remember that these local addresses can share stack frames, right? Because let's say we have this is at +1, this is at +2. Let's say we have some if statement, right? Whatever inside there, where let's say we make there int z, right? In z, that's going to be at +3 when we're inside that if statement. But then let's say outside that if statement, right? So we're outside the scope of the if statement. So we're no longer using +3. Let's say over here we make another int called j. This is also going to be a +3, right? So that's kind of another idea that you have to remember, that when you're outside the scope of something, that's going to be unallocated through garbage collection, and then the next variables are going to go ahead and take that up. Okay. Again, any questions about that? Okay. So to access global addresses and to access local addresses, there's two different ways that you do it. Again, we're working with a stack, so we need to push the address that we want to the stack whenever we want to access some variable. So for global addresses, you use push stat address. That stands for push static address. Looks like this, push static address. And to the right of that, you put the address that you're trying to access. So let's say you want to access X, which is at address 0. You would say push static address 0. Okay. And for local addresses, right, including parameters, right? So this is including M and including A. You use push loc address. That stands for push local address. And to the right of that, you put the address, right? So, for example, let's say you want to access A, you would say push local address -2. Let's say you want to access M, you would say push local address 1, which again, we did say +1, that stands for offset +1. But when you do push loc address, it knows that it's like the offset plus whatever number you put. So you don't have to put the plus sign. You can say push loc address 1, and it's going to know that you're referring to offset +1. Okay. So any questions about push static address and push local address? And again, I said don't put the plus sign. But if you are working with these, you have to put the negative sign. So plus sign you have to put, negative sign you must put. Okay. Now, to access the value inside of a variable, you first need to push the address of that variable, and then you run the instruction load from address, right? What that's going to do, let's say we have this stack here, and let's say X contains the value 10. Let's say X is at address 0, so we're going to say push static address 0, that puts 0 on top of the stack. Then when we say load from address, that's going to pop the top of the stack. Okay, so now our stack looks like this. Now our stack looks like this. And it's going to push to the stack what came from X. So what was inside of X, which X had 10. So 10 is going to be the top of the stack now. That's exactly what load from address does. Now let's say you're working with an array instead, where let's say X is some array, right, whatever, and it has like some memory allocated to it by running heap allocate, which we'll get to in a bit. Instead of returning some value, it's going to return the first address of that array. So you're not always going to be returning a number when you say load from address. Well, actually, it's still going to be a number, but it'll be an address. You get what I mean? But yeah. So that's an example of load from address for integer values and array values. Okay. Now to save a value to a variable, meaning let's say you have int x, and let's say you wanted to save the value x is equal to 10 to x, right? So for that, you would use the instruction save to address, which what you need to do first is you're going to push the address of the variable that you want to change. So let's say we're changing x, and let's say x is at address 0. That's what's going to get pushed to the stack. Then we're going to push the value that we want x to be. So if it's a number, let's say we want it to be 10, we're going to push that value. So now we have 10 on the stack and 0 on the stack. From there, we're going to call save to address, which what that's going to do is it's going to pop the 10 and pop the 0. So now our stack looks like this, nothing in it. Okay. So nothing's going to go back into the stack after running save to address. What's going to happen is it's actually just going to save that value to wherever that address is. So x is equal to 10 now. And that's all save to address does. Okay.
Can you show an example for saving to address if this address is like a array?
If it's an array?
Yeah.
Yeah, we'll get to that. Where is that? We'll get to it right here, actually. So we'll get to that on the next slide.
Thank you.
Okay. So yeah, that's saved to address. Now, when you're going through lines, you're also going to hit title lines of functions. Okay. So for title lines of functions, the instruction is going to be init stack frame, and the number is going to be the number of it's going to be the number of local variables inside your method. Okay. So it's going to look like this: init stack frame with no C, right? I messed up with that on myself, but it's init stk frm. So init stack frame and the number of local variables. So let's say here we have this function g, and when we hit that line, we need to write our instruction for it. We're going to say init stack frame, and we see we have two local variables, so the instruction for that is going to be init stack frame 2. Okay. And that's all it is for init stack frame. Any questions about init stack frame? And again, don't get confused. Let's say if we have something like this. Int x, int y, if blah blah blah, int c, int z. So let's imagine that this code here is inside of G. How many local variables does G have? If this is inside of G.
Wait, so the int c is inside the if loop?
It's inside the if statement, so you could like.
So I think we'll choose two local x and y.
You said what?
Yeah. How
No,
about
the z is not inside the if statement. Only the c.
So 3.
It'd be 3, right? Some people might say 4, which it's not 4, right? And here's why: you would have this at +1, this at +2, and here when you get to this position, you're gonna allocate this to +3. But since this is local to the if statement, once you get out of the if statement, you're never going to be able to use it again. So it gets deallocated. So there's nothing at +3 again. But then once you hit this z, this is going to be +3. So if this was the case, then the instruction for public static void g, that's going to be init stack frame 3. Okay. Any questions about that? That's a very important part. What if there was 2 variables inside the if block? Then how many locations do you allocate in init stack frame? So you need to, for init stack frame, you need to allocate the number of like, you can kind of think of it as like the number or the highest number that needs to be allocated. So let's say if it was like int g here, this would be +1, +2, +3, +4, and then this will go back to +3. So at most you used 4 stack frames, so you would need init stack frame 4, because you need to have 4 stack frames in order for G to run, right? So in that case, you would have 4. Does that make sense? Yep, no problem. Okay, any other questions about this? All right. And then the final instruction for a method that isn't main, right? So let's say if it's some other function G, let's say it's like public static void G or public static int G, right? The final instruction for that is going to be return K, where K is equal to the number of parameters in that function, right? So let's say we have the function public static void G with no parameters, then the last instruction for that method is going to be return 0. Even if it's void, the final instruction is still going to be return and then something, right? Another example, let's say it is public static void G with the parameter int x. The final instruction is going to be return 1. Another example, let's say it's public static int G, int x, int y. If that's the case, the final instruction is going to be return 2 because it had 2 parameters. Okay. But if it's main, right? Main is the only method that's going to have a different ending, where the final instruction for main is always going to be stop. Regardless of the rest of your code, the final instruction for main is always going to be stop. Okay? Please don't forget to write stop. Oh, someone's mic is unmuted. Frostbite. Thank you. Right, the final instruction for main is always going to be stop. Okay. Any questions about final instructions for methods? Nope. Okay. And then here, to call a function, you would use the method call state method. It's not call stat method. It's not anything else. It's not call stack method. It's call state method. You have to remember that letter by letter. Call state method and then K, where K is the address of the first instruction of that method. So for example, let's say we're in main and we're passing some values to a function and we're about to call it, but we don't know the address yet. That's fine. Finish the rest of the code until you find the address of the first instruction of that function. Once you do, go back to call state method and put that address there. Isn't it call state method? No. If you check his thing, he put an E. Unless it was a typo.
I don't think there's an E.
Then where did I read it with an E? I think
It shows up a
in
lot
one
of
of
times in the
his.
file. He probably did a typo somewhere.
Yeah, I saw there was some. I think it. Oh wait, it might have been in the one that's like that has A to F. Or yeah, no. I think it might have been in the hints somewhere. I remember seeing it with E, but okay, I guess this doesn't have an E. Let me. Where is it? Right here. So let me get rid of the E. So then it just represents stat. Just represents static. Just like when you say push static address, right? So call static method, and it's called static method. Yeah, makes more sense because call static method, you're calling an actual static method, public static. So yeah, okay. Anyways, so call static method, and then the K is just the address to the first instruction of that method. So again, let's say we're inside main, we're calling function G, and let's say the first instruction for function G or method G, whatever you want to call it, is at address 36. Then you're going to say call state method 36. That's how you actually go ahead and run that function. And then once that instruction has been executed, it's going to return the value of that function call to the top of the stack. Okay. But before running call state method, if your function has parameters, you need to also use the pass param instruction. right? So let's say, for example, we have this function here. We're saying x is equal to g sub 17 sub 18 of x divided by y. If we wanted to run this here, assuming that g is, I think I wrote it here. Yeah, is at address 100, right? First, we need to push the static address 0 because we're saving into x. So we're going to say push static address 0. Then we need to push the parameters of x of g. So we're going to say push num 17. That does the 17. And then under saying push num 17, we're going to say pass param. That's what actually passes it as a parameter. Then after that, we're going to say push num 18, pass param. That's what passes it as parameter. And then we need to put the result of x divided by y at the top of the stack and then call pass param. So we're going to say push static address 0, load from address, then push static address 1, load from address, then div, right? That puts the result at the top of the stack, and then call pass param. So now we've done all the parameters. Once we've done all the parameters, you run call stat method or call static method with k, and k we said is 100. So we would say call static method 100. Once that's done, the result of this will be at the top of the stack, right? So once this is done, you're gonna have the address 0, and then whatever the result was here, let's call the result A. From here, you need to call save to address, so it's gonna pop A, it's gonna pop 0, and it's gonna say x is equal to A, where A is some value, right? And that's exactly what I did here. Okay. So any questions about call state method? Oh wait, let me get rid of the E from here too. Okay. Any questions about pass param or call static method? Nope.
What's the last one? Save to address.
Save to address. That's what actually sets x equal to this value. Right. I was running this entire thing here.
Okay, I got you. Thank you.
Yeah. Mm-hmm. Okay. Now we're dealing with arrays, which this is what Olivia was asking. So if we want to make an array, let's say we say int x. Let's say we have some source code, right? And the first thing outside of main, right? So the first global variable is x. So it's at address 0. But it's saying int x is equal to new int 10. Right? So we're not just setting it equal to a number, we're setting it equal to an array of size 10. Okay? So here it's a bit different. We first need to push static address, and that static address is 0, right? Because it's the first global variable. Then we need to push the dimension of the array, which is 10. So we're going to say push num 10. Once here, we need to allocate space for this array in our heap. So we're going to run heap alloc. And what that'll do is it'll pop 10 from the top of the stack and allocate 10 like slots of memory for our array. Okay. Once we do this, it's going to return a pointer to the first address of this array to the top of the stack. And then we can call the instruction save to address. Okay. And that's all we need to do for making an array. You can see it here. push static address 0. Here that we did the dimension of 7. Well, it's one dimensional, but it has 7 slots. I keep saying dimension, but you know what I mean. We push the number 7. We call heap allocate, and then we save it to the address. Okay. So any questions about making arrays? Okay. Also, on the exam email he sent, he said that you also need to know how to do this. Right? Where here, it brings upon another component. Where we're saying, okay, now this is 2-dimensional, but we didn't specify what dimension. Right? So if we didn't specify what dimension, then we don't need to allocate that space yet. So all we need to do is say push static address 0 push num10, then heap allocate, then save to address. Right? So that's all I need to do. It's the same exact thing we did as before. Right? If it actually like specified the number here, then that'd be different, which we didn't learn that yet. You need to know that for exam 3, which I think that's in the required reading. Which he kind of fucked us with that because he's not teaching it himself. He's making us learn it ourselves, which is really annoying. But they're the same thing if the dimension wasn't specified, right? Because we're just saying, what's it called? We're saying here that for each byte, we can have an array, but that array can be of any size, so we don't know it yet. So we'll allocate that size when we need to. But here, let's say if we put like 10 and 2, then we know that for each 10 slots of memory, for each of those, for in that 10 slots of memory, for each slot, we need to also allocate 2 slots of memory, which, that's when it gets a bit weird. So that's when you actually have to change the instructions. But since we don't know this, it's not any different. Okay? So any questions about making arrays if it's 1-dimensional and the number's known, or if it's 2-dimensional and the row number is known, but the column number is not known? Sorry. No questions? All right. So then when we're actually working with the arrays, we can call upon values in the array, and you can change values in the array, which I'll do the change values first. So to change a value in the array, let's say we have some array x, and let's say this array x is at address 0. What we need to do, also we're assuming that the array has already been initialized, okay? What we need to do is we need to push the address of x onto the stack. We need to load from that address to receive the address of the first element in this array. Then we need to push the index that we want to go to. So let's say it's 20. We're going to push num20. And then we're going to run the instruction add to pointer. What this is doing, remember we said load from address with x, right? So that gives us the first address of the first element in the array. Then if we push the number 20 and say add to pointer, it's going to pop 2 values from the top of the stack, 20 and the address. It's going to add them together and put it back on the stack. Right, so let's say the first address of our array is at 100. Let's say we have 20. If we run add to pointer, then the top of the stack is now going to contain 120. And 120 in the heap, its address is what x of 20 is contained at address 120. those are just arbitrary numbers, but you know what I mean. So once we actually get that address at the top of the stack, then we're going to push the value of what we want to save. And once that value is saved, then we want to call, once that value is at the top of the stack, then we want to call save to address. So again, here, we're going to push static address 0, load from address, push num20, add to pointer, push num 1000, save to address, right? Which is exactly what we do over here. Push static address 0, load from address, push num20, add to pointer, push num 1000, save to address. And that's it. So does that make sense, Olivia? I know you were asking about saving values in arrays.
Yes.
Okay.
For my understanding, it's like when you load from the address, you are loading the the top of the array, and then you push the number 20 added to the pointer. Is move the pointer from the top of array, move 20, and then the address of.
Yeah, it actually makes it move forward by 20, so you're actually getting to it, right? Because you can imagine the first address being, like, if you truncate it all the way down, you could think of the first address as 0, and if you do 0 plus 20, then that is actually still x of 20. So that address is the correct address corresponding to x of 20.
Thank you.
But now let's say you don't want to change the value at a certain index. You just want to access what's at that index. Again, you're going to be doing the same thing. Let's say I want to access what's at x of 20, right? So ignore this portion here. Let's say I just want to access what's at x of 20 and have that at the top of the stack. What I can do is I could say push static address 0. Again, x is at address 0. Then we're going to load from address to get the first address, to get the address of the first element in the array. Then I'm going to push the number 20, and I'm going to call add to pointer. So now we're going to be pointing to the 20th element, no, not the 20th element, technically the 21st, but we're going to be pointing to the address that contains x of 20. Okay. And then we're going to call load from address, and that'll actually go inside that address, grab the value, and put it at the top of the stack. So from there, we would have x of 20, that value at the top of the stack, and we can do whatever we need to do with it, right? And that's exactly what I do up here, where let's say I want to print x of 20. Again, if I want to print x of 20, I need to get the value. So I'm going to say push static address 0, load from address, push num20, add to pointer, load from address, and then here we have a print for an integer. So we can say write int, but then we also see we have a new line instruction. So we could say write lnop, right? And then that'll finish it off for us. So here, push static address 0, load from the address, push the number 20, and add it to the pointer. Then we just simply load from that address and print the integer by saying write int, which we'll go over print statements in a bit, but we'll use write int, and then we go to the next line by saying write lnop. So keep a close eye. If there's a print statement on the exam and it has ln, make sure to say write lnop as well.
So if we're printing a string,
it could be a string or an integer, and if it contains ln, you have to make sure to say write lnop as well.
Oh, okay.
All right. Now let's move on to while loops. So while loops, best way to explain it is to kind of just show it. So let's say we have this while loop here. And let's say that this while loop instruction is at address 46. Okay. So to do anything first, we first need to evaluate what's inside of here. Okay. And we see we have this AND. But to evaluate what's inside of here, we have to evaluate what's to the left of the and what's to the right of the and. And then we're going to run the and instruction. But first we have to know what this is and know what this is. So first, we're going to put at the top of the stack the value of x is greater than 1. Then we're going to put at the top of the stack the value of x is less than 20,000. And then finally, we're going to run the and instruction, which is just and. Okay. Once you run that and instruction, the value of this entire thing will be placed at the top of the stack. Right? And from there, we can use an instruction called jump on false. What jump on false does is it's going to pop the value from the top of the stack, right, which was the value of this entire part, and this entire part either returns 1 or 0. 1 for true, 0 for false. And jump on false, what it does is it checks if that value is 1 or 0. If it's 0, it wants you to jump to the outside of the while loop. But if it's 1, it just wants you to continue with no jump. Okay. But jump on false, we need to know what what address we need to jump to. But when we're actually writing this, we don't know what the address is yet. So you're going to keep that blank until you get to the instruction that's immediately after the while loop. And when you do, that's when you would put that address to the right of the jump on false instruction.
Sorry, quick question. Why doing the review notebook review whatever. So I noticed there's a jump to false and there's another jump. So when do we use jump?
Yeah. So jump on false, that's usually used at the beginning of a while loop or an if statement. But jump is like a guaranteed jump where it's like regardless of anything that's on the stack, you are going to be jumping to that instruction. So like let's say when we finish this instruction here, there's no other instructions, so then we're immediately going to want to run a jump instruction, and the address we want it to be the address of the start of this instruction, right? Because we want to be able to go back up, right? That's when you use a jump or jump on false, where jump on false is based on some conditional, whether it be an if statement or a while loop, and a jump is usually used to get to the top of a loop, which you're going to see in this example here.
So you mean like after x equal to x plus 1, we should use jump?
Yeah, after we complete the instructions here, since there's no more instructions in the while loop, we're going to want to run jump with the address of the first instruction of this while loop, right? But that address we know to be 46 because we said that we're starting at 46. So at the end of the while loop, we would say jump 46.
Oh, so it becomes a loop doing a
jump. Yeah.
So, but what if x is bigger than?
So if this equates to false, right?
Yes.
Then we don't want to hit that jump, right? And we also don't want to do what's inside. So again, remember this gets equated, and then we run jump on false. So the address after jump on false, we want that address to be the address that's directly after the jump. So we skip over everything, including the jump, right? And that's exactly what we need to do.
Okay, got it.
Right. So you'll see it over here, right? We first need to equate this. So we equate the left side of the and then the right side of the and. Again, assume that x is at static address 0. So we're going to say push static address 0, load from that address so we get the value x, and then we push the number 1. Once we do this, we see that we have a greater than, so we're going to run the greater than instruction. And that'll put the value of the greater than, or that operation, it'll put that at the top of the stack. And then to do this portion here, we're going to push static address 0 again because we're dealing with x. And we're going to load from address to actually get the value. Remember, if you want to actually get the value, you can't just push the static address. You have to remember to load from the address. Then you're going to say push num 20,000. That pushes that to the top of the stack. And we see we have less than. That's going to pop 20,000 from the top of the stack. And it's going to pop the value of x. And it's going to evaluate x is less than 20,000 and put that value on the top of the stack. So once this entire portion is done, the top of the stack is just going to contain two things. The value of the greater than and the value of the less than. So let's say if it's like 0 or 1, right? That would be what our stack would look like, right? From here, we have an AND instruction. AND is a binary operation, so it takes two operators. So it's going to pop twice from the stack and take those 0 and 1 values and say, okay, if they're both equal to 1, then we're good and we're going to return true, right? So then we're going to put 1 on top of the stack again. But if they're not both equal to 1, then we're going to put 0 on top of the stack, right? So AND is just going to either have 0 or it's going to have 1 on the top of the stack. Then we have jump on false, which I kind of spoiled the address there. I'm sorry, but you're going to see what that address is. Where here, let's say we have this jump on false, and let's say the AND is 1, right? So this gave that value. When we call jump on false, it's going to pop at the top of the stack. So now our stack looks like this, right? And it's going to say, okay, is that value equal to 1 or 0? Now remember, 0 represents false. So if it's equal to 0, it's going to jump to this address here. But if it's 1, meaning it's true, it's going to ignore it and it's going to continue down. Right? So in our case, it gave 1, so it's going to continue down. And here it's going to run this instruction here. X is equal to x plus 1. So to do this, x is equal to x plus 1. Again, we're loading into x, so we're going to push the static address 0. What are we loading into x? We're loading x plus 1. So we're going to say push static address 0, load from address, push num1, add, and then save to address. Right? So that's exactly what we do here. Push static address 0, push static address 0, load from address, push the number 1, and then we put the result of adding that on top of the stack. And then we call save to address. Now, note that we are at address 61 now. Okay. And there's no more instructions. Since there's no more instructions, the last instruction for a while loop is always going to be a jump to the address of the first instruction of that while loop. Right? So here, the address of the first instruction is 46. So the last instruction is going to be jump 46. Okay. And then from here, since we have found the address of the last instruction of our while loop, then the jump on false is going to be the address the address after the last address of the while loop. So here it was 62. The address after that 63. So the jump on false is going to be 63. Okay. And that's it for while loops.
About if, does the if end there with jump to?
Sorry?
The if statement.
Mm-hmm.
It also end there with jump.
Yeah, so if you said for if statements?
Yeah, like if loops.
You would have a jump if you have else if and if, right? If like let's say if it was just like if and then something, right? whatever, right? But there's no else statement, right? So whatever's after that, you want to run. If this is true, then the last instruction of this if statement is not going to be jump, because you don't want to jump anywhere. You want to continue downwards, right? But if it was like else if, right, but we actually ran what was inside of here, then the last instruction of this if statement is going to be jump, and it's going to be skipping over all the else's to the next instruction after all the else's. So it just ignores everything there, right?
Okay, I see. So
Yeah.
basically, you are saying like, if we have a if and we have another else if the the first if loop we have like, for example, if we have jump to the false and it is a false, then we should put the address of the instruction of the else if after the jump to the false.
Yeah, I'm saying like this, where let's say we have this if statement, right?
Yeah.
We're going to evaluate what's inside the parameters, and then after evaluating it, let's say we have if, else, if, else. After evaluating it, we're going to have a jump on false to the address of the else if.
Okay.
And then the else if, we're going to evaluate this, and we're going to have a jump on false to the address of the else. The else is not going to have a jump on false because we're not evaluating anything. We're just running what's here, and then we just continue all the way down. But the last instruction of this if statement is going to be a jump to the address after the else statement, right? So outside of it. And the instruction at the end of this else if is going to be a jump to the address outside of the else statement as well, because we don't want to run anything here.
Wait,
if this equates to true.
I thought at the end of the if loop, we will have a jump, but the jump will jump to the to the if, the top of the if. Like,
well, this isn't a loop, right? In a while loop, you would have that, but this isn't a loop. You would just run what you need to and then jump out.
Because you have to test if and else if. Oh yeah, I see. I got you.
Yeah. Okay. All right. Any other questions about this from anyone? That kind of touched on while loops and if statements, which actually I think I forgot to touch on if statements, so I'll do that with you guys live. Okay. So here, what was I doing here? Okay. This touches on discard value. So this is just some niche things that you need to know. So let's say you call a function, right, that returns a value. So like let's say you call a function that's int g, right? So we're supposed to be returning some value. But when you're calling that function, you're not returning it to anything. You're not returning it to some expression. You're just saying, okay, you have some code here, and you say g like 17, whatever, right? And some code here. You're not saying x is equal to g17. You're not saying x divided by g17. You're not saying anything, right? You're just saying g17. But you're supposed to be returning some value. Now, this can happen for a number of reasons. Let's say inside of G you want to edit some global variable, so you do that, right? But for some reason you're returning something, I don't know why, right? If you return something and it's not being used, you want to run the instruction discard value. What that will do is, remember when we finish G using call state method, call stat method or call static method, when we finish that, and the value of that gets put at the top of the stack, if it's never used, then we run discard value. So here's an example here. Here we run G17. So we push the number 17, pass it as a parameter. We run call stat method. Remember, I put the E by mistake. Right, we call stat method. And then we notice that nothing happens with that value. So after that, we run discard value. Okay. So again, this is just a kind of niche instruction that you have to remember. Any questions about that? And again, if it's like a function that's void, of course it doesn't return anything, so you don't need to run discard value ever for any void functions. So yeah. Okay.
So, wait. So you are saying like, if this method is not returning anything, we just put discount value.
No, so when it is returning something, but it's not returning into anything, so like it's not returning to an expression, it's not returning to an operation, anything like that. Let's say you just have one blank line, and on that line is just G17 or G whatever, right? But it has a return value, then you just run discard value.
Oh, so you're saying like the method is wrong, but it's not like the value it returns. We're not gonna pay for anything.
Yeah, like if it returns a value but you don't do anything with it, then just run discard value.
Okay, got it.
Okay. Another nice instruction you need to know is some value or whatever you do it, and then you say input.nextInt. To run input.nextInt, you simply run the instruction readInt. It would make more sense to say nextInt, whatever, I don't know. But we use readInt. So all that does is it takes the value of input.nextInt. It's going to be some integer. When you call readInt, it just takes that value and puts it at the top of the stack. So here, for example, let's assume that x is at global address 0. We push static address 0 because we were saving to that address. We call readInt. That takes this value and puts it at the top of the stack. And then we call save to address, and that's it. So that's just another thing you need to know. We went over. We actually we didn't go over. We just touched on it. WriteInt. That's just saying, okay, it's going to pop an integer from the top of the stack and print it to the console or the screen, whatever. And then write lnop. Let's say you have some print statement, but it has an ln, so it's not just print; it's print ln. Then you're going to want to print whatever that value is, and then after that, run the instruction write lnop. That'll take care of the new line for you. Okay. Finally, we have write string. This is just like if you're doing like system.out.print line, and then inside of the parentheses you have some string that you want to print. You have to run write string AB, where A is equal to the address of the first character of that string in static memory, and B is equal to the last address of that is equal to, wait, sorry. B is equal to the address of the last character in that string. Okay. So in this example here, we have two global variables, x is equal to 10 and y. So x is occupying address 0 and y is occupying address 1. We have no more static addresses. So when we run, when we run system.out.println, the cat, the first character is going to be at address 2 because 0 and 1 are already being occupied. And the last character is going to be at address 8 because if you just put it all out, H is at 3, E is at 4, the space is at at 5. I don't know why I said S. Which, even if there's spaces, you have to account for that too. So space is at 5, C is at 6, A is at 7, and T is at 8. Right? So here, if we wanted to print this, of course, we would deal with the global variables first by saying push static address 0. Then we're going to say push num 10. Then we're going to say save to address. Then inside of the main function, we're going to say init stack frame 0 because there's no local variables, right? And then we're going to say write string AB, where A is 2 and B is 8, right? So we're going to say write string to 8. And then under that, we see that it is an ln, so we're going to say write lnop. And then under the write lnop, we see that there's nothing else here, so we're going to say stop because it is main. So we're going to put the instruction stop. And that is what this looks like. Right, so this is equivalent to that.
So I have a quick question about the y, the global value y. Do we need to like push stack address?
So we don't need to push that because we didn't set any values to it. the computer already knows that that's at address Y, so we don't have to do anything with it. We only need to do something with it if if we see that we're doing any arithmetic or operations with it, then we push it. But here we're just declaring it, so we don't have to do anything. Mhm. Any other questions about write int, write lnop, and write string ab, or about read int and discard value? Oh, okay. And then just some final operations that you need to know for Java Virtual Machine is plus is add, minus is sub, multiplication, that's mul, which remember, don't confuse this with descent parser code, where add in there is plus, subtraction in there is minus, and I think that's it, right? So just don't confuse those. So yeah, everything else I believe is the same. Then divide is div, modulus is just mod, less than is LT, greater than or equal to is GE, greater than is GE. Pretty simple. Equals, that's just EQ. Not equal to, that's NE. Not, or the not symbol is just not. And is just and then the or symbol is just or. Okay, so that's some things you need to remember as well. So before we jump into,
Do all of you guys remember those machine terms? Do you remember all of them?
I wouldn't say that I do. I feel like it just comes back to me when I'm there. Yeah. I wish those symbols were in the course reader. That would probably help. I don't know why he doesn't do that, but not much you can really do.
I wish we had a cheat sheet.
Yeah, that would help, but not much you can do. Oh, I forgot one more thing. One last instruction. We've gone over all the instructions, but now this one is change sign. All that does is it pops the integer from the top of the stack and returns the same integer but with the sign change. So let's say 17 is at the top of the stack. If you say change sign, it's going to pop from the stack and push to the stack -17. And if -17 is at the top of the stack, if you run change sign instruction, which there shouldn't be a space in between them, I'm sorry. If you do that for -17, that's just going to give 17, and so on. Okay. And then one final thing we didn't get to touch on, like actually show the virtual machine code, is the if statements. So let's say if we have if x is greater than 10, run x is equal to x plus 1. Else if we'll do x is greater than 20, x is equal to x minus 1, and then I'll do else x is equal to x divided by 10. All right, that's just some random stuff. So this is the last thing we're going to do for virtual machine stuff, and then we're going to go to part 4. Okay. So here, again, let's assume that x is at static address 0. And let's say we're at instruction 46. First thing we're going to do is push static address 0. And then we're going to push num 10. Oh, let me put it over here. 10 with 47. And then finally, we're going to run GT. So this is going to put the result of x. Oh, wait, sorry. I forgot to load from address. Fault. No, I didn't catch that. Load from address. Okay. So what this is going to do is it's going to put the result of x is greater than 10 at the top of the stack, and that result is going to be 1 or 0. Okay. Now, if it's 0, we want to jump to this instruction. But if it's 1, we want to continue doing this instruction, and then once we're done, jump all the way over here. So we're going to run 50. We're going to say jump on false. Right? So we don't know the instruction of the else if yet. Or sorry, we don't know the address of the else if instruction yet. So we're going to keep this blank for now, which is what you're supposed to do on the exam. Keep it blank. And then continue and do what's inside the if statement. So here all we have is x is equal to x plus 1. That's easy. We're going to do push static address 0, push static address 0, load from address, push num1, add, save to address. Okay. Now you might think to yourself, okay, we did this and there's no other instructions left. So that means that the address of this instruction, of that line of code must be 57. Well, if you think that, you're wrong. Because this instruction, we need this to, once we're done, we don't want to look at anything here. So we need this line of, this instruction to jump out of that if else branch. But we don't know the address of what's after the else yet. So we're going to say jump and we're going to keep it blank for now. Once we know that, once we finish the jump, which is the last instruction of this if statement here, then we know the address of this statement, which is 58. So we're going to go to the jump on false and put 58. Okay. And then now we need to do this else if, which first thing it does, x is greater than 20. So we're going to push static address 0. Then we're going to load from the address. So 59, load from address. Then we're going to push num20. And then we're going to run greater than, right? So greater than. And then here we're going to have another jump on false. So jump on false. This jump on false is going to jump to the address of the first instruction of the else statement. We don't know that yet, so we're going to keep it blank. Okay. Now here it says x is equal to x minus 1. All right. So 63. That's just going to be. Go. It's just going to be push static address 0. Push static address 0. Load from address. And then we need to put a 1 because -1. So we're going to say push num 1. Okay. Then we're going to run sub. And then we're going to run save to address. Okay. And then once we're here, we have finished this else if. But again, that address is not equal to the address of the else statement. This address, now we need to have the jump statement, which jumps to the address outside of the else statement. So here, 69, we're going to say jump, and we don't know that address yet, so we're going to keep it blank. Now we're going to do the else statement. Again, we don't have a jump on false here because we're not checking anything. Okay. But before doing that, we know that the first address of this instruction is going, or this line of code is going to, for the else is going to be 70. Now, we knew that this jump on false here for 62, this needed to jump to 70. So we're going to put 70. And now that's filled up. Okay. And now last thing we need to do is x is equal to x divided by 10. So that's going to be push stat address 0 push static address 0 load from address, and then we're dividing it by 10, right? So we need to push the number 10, so 73 push num 10. Then we're going to call div, so 74 is div, 75 is save to address. Okay, and that did this part. Now here, for the last instruction of else, we don't need a jump on false statement because there's nothing to jump to, right? After this else statement, then we're just going to run whatever instruction is after that else statement, right? So we don't need a jump on false statement, and that means that we have now found the address that's on the outside of that else statement. So we can go ahead and put that here, 76, and up here, 76. And that's it. So these, this whole line, this is what, 30 lines? That was all for this. Okay, so this is that. Okay. So any questions on if statements? Or are you all good with if statements?
Yes, sir.
Good. All right, so that was it for virtual machine. Any last minute questions about virtual machine code? If not, we're going to move on to number 4.
So sorry, but
Sorry, your mic is cutting out.
I see. Can we take a little break?
Oh yeah, sure, we can. What time is it? Do y'all want to take a 5-minute break and then we'll move on to number 4? Sound good? Yes, no? Y'all can put it in the chat if you want. See some people typing in general. Yeah? Okay. We'll take a 5-minute break. So what time is it? 11:37. So we'll be back at 11:42. All right?